about problem 53. And I will talk about the first two parts, and my partner Yusuf will talk the second two parts. And the problem is there is a deformation map, which is given here, and asks us to calculate the C matrix and the E matrix, and also get the eigenvalue and eigenvector of them. And firstly, we are going to calculate the C matrix. And from the book, we know that the X equals the VZ, and then we can got X1, X2, X3 equals to these three parts. And then from the definition, we know that F equals the gradient operated on the V function, and then we can get the F matrix, which is very straightforward. Take the derivatives of the V respect to Z1, Z2, Z3, and we got this matrix. And also, since the C matrix equals F transpose times F, and then we got the F transpose and F, and we may make a product of these two matrices, and we got the final C matrix, which looks like this.
Great. Nice one. That was good.
Oh, that's cool. Okay, so you start?
Yeah.
All right, after we got the C matrix, and now we can calculate the components of it. Since he asked to calculate the components when Z equals 1, 1, 0, and we can substitute this value into the original C matrix and get the components of C, which is like this. And after we got the C matrix, we can now calculate the string tensor. And from the definition, the string tensor equals a half of C minus the identity matrix, and then we substitute the number into it. We can get the string tensor looks like this. Right.
Eigenvalue and eigenvector of C and E. For C, we know that determinant of C minus mu the I, which is the identity matrix, is equals to 0, and the determinant of C minus mu I is given like this, which is C minus mu on the diagonal. So that gives us this, which is 1 minus mu in bracket 13 minus mu multiplied by 17 minus mu minus 14 times 14 equals to 0 according to this equation. So with that, after solving this equation, we get mu to be the values of 0.85791 and 29.142. The question asks us to find the maximum stretch, which is what we're going to do next. Stretch, the square of the stretch, it is the same as the eigenvalue of the matrix, which is shown in this case as this. With this, we get a minimum value of 0.9262 and a maximum value of 5.3983. Using the maximum value of the stretch, that is mu3, which is the square of this 29.142, and the formula which we've used earlier, C minus mu I in bracket n is equal to 0 to find the eigenvector n. We put mu of this into the equation, into the matrix, and solve it using the we get n3, values of n3 to be 0.6552, 0.7555, and 0. And remember n3, which is a unit vector. But as we use for the maximum stretch, with the minimum stretch, that is at mu1 equals 0.895, to find the eigenvector, we get the value n1 equals to minus 0.755, 0.6552, and 0, which is also a unit vector. Also, if we can recall from our previous slides that E equals 670, equals this tensor 670, 780, and 000. We are required to also find the eigenvectors and eigenvalue of this tensor. We use the same method that we used for the C, which is determinant of E minus mu I n equals 0, where E minus mu I is this, and the determinant of that equals to 0. It will come from the formula of determinants, which is plus 6 minus mu times 8 minus mu minus 7 times 0 multiplied by minus 7 equals this, and minus 7 times minus mu. That gives us a value of mu to be minus 0.0711 and 14.0771. And this is the minimum value, and that's the maximum value. The value of the eigenvector values is gotten here, and we get a corresponding eigenvectors of n1 of minus 0.7555, 0.655 to 0, and n2 of 001, n3 is equal to 0.655 to 0.770. This is for the minimum, and y that is the maximum. We can recall from the values we've gotten for C, which is for the stretch. It shows that the principal strength of this particular, what should I say,
Direction.
The direction of this principal strength is the same as that for the principal strength for the object. Thank you very much. I hope you enjoyed our question, our solution to the problem, and I'll see you there another time.